Hello everyone, I'm Sude and Keleş. I'm a third year physics student and this is our Phys-212 lab project. In this project we are investigating beta particles penetration through different obstacles using two different sources. This is our experimental setup. Here we have a vacuum chamber and using this vacuum pump we extract air from this vacuum chamber. Here we have our radioactive source. We placed an obstacle in front of the radioactive source. We have our Geiger counter and here we have our Arduino, and using this Arduino we are taking data using the computer. In our experiment we used two different radiation sources. Initially, we wanted to use an alpha source in our experiment to see the difference between beta particles penetration and alpha particles penetration. However, in our labs, we couldn't find any alpha sources, hence we used two different beta sources. The first beta source is the strontium-90 and the second one is cesium-137. In the experiment, we used three different obstacles. The first one was a 2 mm aluminum plate, the second one was a 3 mm copper plate, and the last one was a 7 mm wood plate. Initially, data was taken in the vacuum chamber with no radiation sources to detect the background radiation, and in the data we observed that there were 10 to 15 countings per minute for the background radiation. In our experiment, the sources used emit beta particles to become more stable. This process is called beta decay. In this process, a neutron can be converted to a proton by emitting an electron and an antineutrino. A proton can be converted into a neutron by emitting a positron and a neutrino. These emitted electron and positron are called beta particles, and they can be detected using the Geiger counter. For beta particles, there is not a single formula that gives penetration through different materials, hence their penetration is usually measured experimentally. In this figure, we see strontium-90's count rates with different obstacles. For strontium-90, countings are very high since it produces high energy electrons compared to cesium-137, and it can be detected more easily by the counter. And without a shield, counts are around 250 to 30, and as density of materials increase, we see a decrease in counts. And as for the densest material, copper, counting rates are lowest as expected, and for aluminum, the count rates are higher. And also copper plate is thicker than aluminum plate, and it also affects the count rates, and hence it is expected that it shields particles more. In this figure, we can see the count rates for cesium-137 for different obstacles. For cesium-137, we have highest count rate with no obstacles as expected, and similar to strontium-90, as density increases, count rate decreases as well. But there is a strike with wood obstacle around 270 seconds, and it's considered an error caused by probably environmental interference or electronic noise. In the experiment, we observed high count rates for strontium-90 and low count rates for cesium-137, which we will explain in the next section actually. And as the density of the material increased, the count rates decreased as expected, and the thickness of the obstacles also affected the count rates. Generally, we found the highest count rate with no obstacles, and the lowest count rate was with copper plate, which provided the best shielding obviously. Beta particles passed through aluminum the most easily, while the wood plate actually had count rates in between. Overall, we can say that no obstacle was effective enough to completely stop the beta particles, because either they were not dense enough or not thick enough to stop them. Now I will mention the decay analysis of our sources. In our experiment, we used sources that were actually purchased in 2006, and actually almost 40% of them were decayed. However, strontium-90 actually decays to a yttrium-90, which is also an active element, and it actually produces very high energy beta particles. However, cesium-137 decays to barium-137, which is actually a stable element, so it does not produce that much of a high energy particles. And also the beta particles created in decay of cesium-137 is not as high energetic as strontium ones, hence they are easily shielded and not penetrating through that as effectively as strontium's beta particles?